Two charged pith balls are suspended on a very light 120 centimeter strings. Each has a mass of 10 grams. Assume that the angle the thread makes on the vertical is 15 degrees and the balls are in equilibrium. Draw an FBD for one of the pith balls and clearly label on the forces with magnitude and direction. Assume that the pith balls are equally charged. What is the charge of the ball? So first off, there will definitely be a repulsion force because they are of equal charge, right? So let's take the left one and draw an FBD. So there is an FE, electrostatic repulsion because of this. There is a gravity which is acting downward, and there is definitely a tension. And if this is theta, then this is also theta. So if you make the components, then this is t cosine of theta, and this one is t sine of theta. And since this is in equilibrium, we need to find we need to first write the equation that t sine theta is equal to Fe, and then we write that t cos theta is mg. If we divide both sides, then sine over cos is tan, then tan theta is Fe over mg. If we flip the equation, then Fe over mg is tan theta. If we cross multiply by mg, then Fe is mg tan theta. And what is Fe? Fe will be k, q1, q2 means they are same, so that's q square over r square. So that is equal to mg tan theta. If you rearrange, then the value of q square will be r square mg tan theta over k. So r is something which is not known to us, right? So let me just try to solve for r. Let me just clear this up because that has already been answered now, because I'm going to now work for r. Now r is the perpendicular, r is the straight distance between them, which is like this, and this is vertical. So don't you think this is a right angle triangle? And if this is a right angle triangle and this is r, and this is already 120, so don't you think that we can use sine? Because if we use sine theta, that is going to be opposite, which is r, over adjacent, right? Adjacent, which is, sorry, over hypotenuse, which is 120 centimeter, but that should be in meters, so 1.2. So if we cross multiply, the value of r comes out as 1.2 sine theta, where theta is what? Okay, let's keep it theta for the moment. So this is what we have to plug it in over here. Let's continue over here. So q square will be equal to r square. In fact, let's take square root both sides. If we do that, then q will be r root of mg tan theta over k. So all we have to do is plug in the value. So r is 1.2 sine of 15 degrees. Root of mass is, I think, 10 grams, right? So 10 grams is what? 0.001. I'm sorry, 0.01. That is the mass. Gravity is 9.8 because we just multiplied with 1000 times tan of 15 degrees over k, which is 9 times 10 raised to 9. Big numbers. Let me just grab my calculator and I think solve for this up. And 0.01 times 9.8 times tan of 15 over 9. Oh, interesting. So we have a square root of this value, which is uh, well, let's multiply with, I think, 10 raised to minus 9 as well. Taking square root of this value, multiplying with 1.2, then multiplying with sine of 15. Finally, the answer comes out as 5.31 times 10 raised to minus 7 coulombs. Thank you.